So the question is, does polymorphism exist in Python? And the answer is that the strong concept of polymorphism, which was there in C++, that doesn't exist in Python. And it is not present in the official documentation either. You can refer to it on this link. And what is the reason behind that? Why that concept doesn't exist? The reason is there are no kind of pointers present in Python, right? So what was the concept originally? What was the concept of polymorphism in C++? So if we quickly describe the concept of polymorphism in C++ was, we used to have a pointer variable of the base class, right? And then we used to have certain objects of derived classes, multiple derived classes, and these were the derived classes, right? And then what we used to do was we used to assign, okay, so this base pointer variable usually was of some array type, right? So it used to have many places in it. So what we used to do was we used to assign these to this base pointer. So we used to assign the derived class objects to the base class pointer. And by doing this, our objective was we used to have some single function which was overridden, right? So some overridden function was present, and our objective was that whenever we run the that function through this base pointer, right? So let's call this pointer p. So whenever we run that function through this base pointer, the correct version of that function should be run. So since this function is overridden, so it means this function used to have a separate definition for each of these three classes, or as many as classes, right? So this function used to be overridden, one thing, and the second thing is it used to have separate definition for all of these classes. So for this class, this function maybe was, you can say f1, right? And in the second class it can be f2, and in the third class it maybe was f3. The name of all these functions used to be same, but the definitions were different. So our objective of this whole concept of polymorphism was whenever we run these different objects which are stored here in p, which is the base pointer, whenever we run this function through this base pointer p like this, right, the correct version of that function should be run. So if if this first object is stored in the base pointer and then that function is run, then the correct definition means f1. If this object is stored here, then the correct definition means f2. And if this object was stored here, the correct definition means f3. Okay, so this was the basic concept of polymorphism in C++. And I was curious, so I tried to implement this in Python. So the conclusion that I came up with is Python is such a flexible language that we don't need all this. We don't need this difficult stuff to achieve the objective. So we can achieve the objective, which is the basic objective of polymorphism, without going into the difficult methodology of this. So let's see how can we do it in Python. So this is the code. Let's see, I made a base class called as animal, and then I initialized some variables in the constructor. You can see there are 4 variables, different variables, out of which 2 must be passed and other 2 have default parameters. And then I made a function make sound. So this is that function I'm talking about. This function should have different definitions in each of the derived class, and we want the correct definition to be run. This is what we want. This is the objective. Okay, so now I derived a class cat with this animal class and another class dog with this animal class, and they both have their own constructors, and their constructors are calling the base constructors. You can see that here. Now you can see that in each of these 2 classes you have that make sound function, this function. So this function is written again in each of these classes here. It is overridden here, right? You can see this make sound function has overridden this function of base class. Again, this make sound function has overridden this make sound function of base class. So we have the overridden definitions of function in the derived classes. Now in the main body of my program, what I've done is I've made 2 objects, cat1 and dog1, of the class cat and dog, and I've passed several parameters here. Now for that objective of polymorphism, that we want the correct function to be run in the code. So what I've done is I've made this for loop here. So this is my array. I've directly written it here, cat1 and dog1, and you can put them both here in one place. So this is the beauty of Python. You can't do something like this in C++ in such an easy manner, right? So I have made an array of two different classes. So it's a compound array, right? And then I've run them in the for loop, and in the for loop, this is calling make sound function. Now, when the object of cat1 will be here, the make sound function of cat should be run. And the object of dog1 here, the make sound function of the dog should run. And you can see that in the output. That is what's being happening. So you don't have to go into the detail of polymorphism, which we used to have in C++. That was a very tough concept. We can still achieve something as magnificent as that with such a simple code. So this is the beauty of Python. So with this, we conclude our today's topics. In the next week's video, we will cover a graphical user interface in Python, the GUI in Python. So see you next time.